Wonderful, Michael, you're the best. Okay. Okay, no, it's okay. It's hard to get thrown into that. Okay, so it says doing unit vectors, so I'm going to turn these into components here. If I want to do u plus v, okay, which is what I'm going to want to do. What am I actually adding as far as components? What is u the same as? Ux, uy, good. So I'm really adding here ux, uy plus vx, vy. I'm hoping I can just add the components, but I can't actually say that. How can I split ux comma uy? What can I split that into? Not yet. That will work, but you can't do it right directly. Let's say use unit vectors. How can I deal with the unit vectors for ux and uy? What do I do? Go ahead. Good. Yeah. I'm going to write an in-between step in here. But you're exactly right. That's what I'm getting into. And what I'm hoping is that we'll end up with something like what Joe said there, right? That'll just hopefully work out nicely, and we can be happy what we got to show it, okay? And what Evan said, he said, this changes into uxi. And I guess someone other than you, Evan, to do the rest in here for me, okay? So I, remember, means the x coordinate of 1, 0, or times it out by ux, whatever it wants. Can someone be brave and give me the next one? 0 comma uy changes into what, please? Somebody else. Uij, good. And j again is going to be vector. Can I get a third person to give me what the x0 changes into? Arden doesn't raise her hand in class. Thank you, Amy. Okay. You can't make her? You can. Okay, can I get someone else other than Arden to give me the last one, please? Arden, good, wonderful, go. Thank you. Now you did it. Okay, that's right. Okay, now here we go. I have to get this back into the other equation. Can somebody give me the moment of brilliance here for how I can combine those now? Because I can't just say therefore it's the answer I want. I need a one in between step here. No, not you. Oh, you guys are totally dead. I'm sorry that I did this to you. This is calculus, the most exciting lesson of the day. How do I deal with it? How can I bring that back into Cartesian form? What do I have to do? Okay, since Michael's helping here, I'm going to write it like this and see if this helps you. I just rewrote that in a different order. Why is that helpful to me? Yes. Very good. So this is going to equal to I times ux plus vx plus j uy plus vy. Now I know what you're thinking, Joe, especially you, and I don't know why I'm picking on you, but I'm going to. You're saying this seems like a lot of trivial sort of stuff to get an answer, okay? In math, you have to prove something's true before you can use it, and it's very important, okay? Because you can't just assume things are true. This is new for you guys, like logically, it logically works, but you actually have to make sure that it physically works too. Okay, this is looking so good. How can I rewrite I times ux plus vx? Oh no! What does I mean again? What does I mean? I is 1 comma 0. So what's I times ux plus vx going to be? Yeah, ux plus vx comma 0. Good. Great. With that help, can I get someone please to be brave and volunteer? Maybe a back row person, since none of you four raise your hands today yet. Can I get someone in the back row to tell me what j times uy plus vy is, please? Oh, the sound of silence. Somebody please be brave.
0 j plus
uy, but yes. Great. Can someone finish this up for me then? How do we add those together? Okay, if this is painful, the whole rest of this next 2 weeks are going to be a nightmare for all of you here. How do we add those two together? Please play along. Combine them. So the x's go with like the first x coordinates go with the x coordinates, the y coordinates go with the y coordinates. So this just turns into then ux plus vx comma uy plus vy. That's a wonderful proof then. So what that means is then, so the example for this says, if I'm adding then 2 comma 3 plus negative 5 comma 8, what does that equal then? Go ahead, Joe. How'd you get that? Just add the components, right? That's cool. Okay, that saved us a lot of time. That's what it did. Joe doesn't think it's cool, so that's okay. Right, it is cool though. That saves tons of time. Scalar multiplication. Here we go. Here we go. We're not done. No big one. Scalar multiplication. Here's a little joke for you guys though. With no giggling. My daughter, who's 3 years old, I don't know what happened to her daycare leader. She said that her daycare leader said he was smiling. And she's 3 years old. Like, how can you tell a 3-year-old not to smile? Is that a smile that's on your face? Math, I better not. Okay. No, who would say that to a 3-year-old? That's awful. Isn't that awful? I want to do some investigating. That's okay.
Sounds like calculus is more fun than daycare.
It sounds like it. It's going to have to be. Scalar multiplication.
She's probably taking it out of context.
I know. I think you're right. I know she is. I'm not making a big deal because her daycare is wonderful, but. Okay, let's do the same thing. So give me the first step. What's for KU? What's the first thing? The same step we're going to follow here. And if Evan, I'm going to pass on you this whole question. I'm sorry because you're the only person trying today. Everyone else is hoping I write down the question. So I thank you for trying, Evan. Okay, but because I'm punishing you by not letting you raise your hand. Okay. Can somebody tell me what to do next? What do I turn vector U into, please?
UX, UI.
Very good. So this is going to be K times UX UI. Now, I know you're thinking to yourself, that's got to be KUX QY. We don't know that, though. We're hoping that it will be. So we got to do the same old rigmarole again. What do I change UX QY into, please? UX. Yeah, the I. Yeah, good. So this is going to be equal to K UX comma 0, and you said IUX, and that will be that in a sec. So I'm going to change that though. So K times UXI, thank you, plus UYJ. Now, so what I've done here is I've changed them to a scalar. That's basically what I've done. Where the reason I can get around a lot of this math is that I is a vector, but UX is still a scalar, right? UX and UI are both scalars. That's why I can get away with this. Now let's use our lovely distributive property. What's the next step in distributive property, please? Someone other than Evan, play along, please. Good. So KUI. KUXI plus KUY, whoops, what was that? No. Plus KUYJ. Okay, we're almost done. What is KUX times I equal to, please? Sorry, the front row is out, middle row or back row is in. What's KUXI equal to, please? Oh, come on, guys, please play along. I can't be talking to myself. You can't see me and Arden talking the whole class. It's not fair. Sorry, Arden. You're in the front row. That's the punishment I'm getting talked by me the whole day. KUXI, please. Oh, pick me. Sorry? Yes, it is. Thank you. I didn't hear whoever said that. Sorry. Great. KUYJ is equal to what?
0.
Thank you. Equals KUX comma KUY. Okay. Okay, our last proof and then we're done here. It's our Cartesian vectors. We're going to say let P x1, y1, and q, x2, y2, be any 2 points on the coordinate plane. Okay, so I'm going to draw a plane, which will be nice. I'm going to call this P. I'm going to call that Q. They can be any points that are on there. I'm also going to call the origin O. I'm going to make some nice vectors. This should look from, oh goodness gracious, I'm the worst triangle maker in the history of the world officially now. Okay.
It's a circuit with a switch.
Yeah, okay, good. Okay, so what I want to find right now is the magnitude of PQ. That's what I want to find using vectors. Okay. How can I write, what is, sorry, let's try again here. Don't want to give away the end. What's PQ equal? What's another way I can express PQ? How else can I express PQ? What is PQ equivalent to? No, you're out. Now you all wrote a test on this yesterday. Negative QP, good. What else though? Okay, now hold on a second. No, you're making fun. Okay, but the thing is here, why is the origin of importance to me here? Why is the origin important to me? Good. Why also?
You can do the components.
Yeah, you can do the components in quite nicely. Okay. All right. So what is PQ equal then, please?
Q.
Wonderful. Now I'm going to use Nate's advice. I don't like PO at all, okay? Because PO I can't find the distance from, okay? Because PO is not a Cartesian vector. OQ is going to be a Cartesian vector. PO is not. How can I make PO a Cartesian vector? Negative OP. So this is going to be OQ minus OP. Now this is something that's fundamentally important. Okay, so it's going to be the second vector minus the first vector. Okay, when you get to Cartesian. Let's get to a few things. Can I get somebody to tell me what OQ is equal to, please?
Q is Q. Wait, no.
And this is going to be a square bracket because you're starting at the origin, right? So it's going from the origin to Q. So 0 to x2 is 0 and the y2 is going to be a square bracket. What is OP going to equal, please? Okay. Using our lovely proof that we just did, how do you subtract two Cartesian vectors? Oh goodness, please play along. I'm sorry this is boring. I apologize. This is only Wednesday. Is tomorrow going to be better or worse? It's a 50-50 shot, okay? So stick with that. What happens here? Go ahead, Amy. Yeah, I'm not going to go. I'm going to just go right to the final thing, though. Okay, right? Because we've actually proved this. We don't need to prove it with components. We can do it right there. Lovely. So basically, the vector PQ is going to be the component of x2 minus x1 minus y2 minus y1, which is nice. How do you find the distance for that then, please? We already learned the distance formula using these type of vectors. What was the distance formula? Do you remember? So basically, I proved this again, which is nice. Now, the thing that gets people difficult on this, okay, because we'll see this a lot, especially in the third dimension too. PQ is going to be the second vector, like Q minus P, think of it that way. Okay, it's always the second vector minus the first one, and that's something that people tend to forget. Okay, so I wanted to do that right there. I think I just do examples and then we're done. Ready? I just do examples and then we're done. That's a good thing. No more talk. I see nothing but misery today, Michael. Do you have a joke to tell? Okay, I'm going to tell a joke then right now since you guys are all miserable. Okay. Let's stop it. Long time.